Hello class, this is lesson 1-10, understanding ratios, proportions, and unit rates. This is a learning needed channel. My request to students in all videos, if you've been with me in lessons so far, this is just a quick reminder to remember your reason to pass the GED test. Use that as your motivation to push through and get that certificate. Second is don't give up. It's not easy, but you will get there. Just keep working at it. And finally, please like this video and subscribe to my channel so that I can continue producing more GED content. I can only do so with your continued support, and I will have videos for all 4 subjects in the future, so keep an eye out. If you are interested in one-on-one tutoring with me, where I can help you live over a video call in anything from working through some practice problems, explaining some of the problems, explaining a subject more in depth, maybe you just want some feedback on how to study or how you're doing, I do have that service available in my website, which is in the video description below. Study material that I suggest to students to use is the Kaplan GED Test Prep Book. They release a book every year, and it looks like that purple book there. It is a pretty thick book because it provides really easy to understand and really concise lessons in all 4 GED subjects, and it is a very handy tool to learn the subjects needed to pass the GED exams, all 4 of them. So highly encourage you guys to check that book out if you do get a copy. You don't need to get the latest year. If you can find one at a used bookstore that is of an earlier year, that totally works fine, because I find that the material stays pretty consistent throughout. They just do some minor tweaks and updates year to year. Second, the only calculator that you are allowed to use in the GED math test is the TI-30XS model. I highly encourage you guys to, if you have a library or some local resources, we can at least borrow the calculator for a little while, learn how all the buttons work. Highly encourage you to do that. If you are interested in getting the latest version of the Kaplan book or the calculator, I do have links to purchase those in my video description below. That way you know that you are getting the correct copy of both of those resources. All right, let's get started. Ratios explain the relationship between 2 different subjects, and ratios are going to be written in one of 3 forms. First is using the word to, so you will see a ratio written as 1:4. Second is with a colon, and you say it out loud the same as the first one. You say 1:4, but it may be written as 1:4. And finally, I'm sure you're familiar with this last form, it is a fraction form. But very important, it is not a fraction. It has a very different definition, and I'll explain that here. Ratios show the relationship between 2 different things, each with its own number. So if I have a ratio of 1/4, I can be talking about 1 pizza over 4 people. And that can apply to a situation where I say something like, I will order 1 pizza for every 4 people that come to my party. So the 2 subjects in this ratio are pizza and people, and it shows what the relationship between the 2 are. If there are 4 people, I will get 1 pizza. This is very different from fractions, because fractions talk about one subject, the same subject. So taking that pizza analogy now in the format of a fraction, I can say it as 1/4 is 1 pizza slice is eaten in a pizza that was cut up into 4 slices total. And that is saying that I ate 1 pizza slice from a pizza that came in 4 slices. In this fraction format, using the same numbers, both numbers 1 and 4 are talking about one thing, a pizza, and it is the same pizza that they are talking about. A very important thing is that ratios in fraction form behave like fractions. In other words, if you get a ratio, you can reduce it to lowest terms, and you can raise the fraction to a higher form, or you can lower it to a simpler form, just like a fraction are. But the very important thing is to know whether you're working with the ratio or you're working with the fraction. Let's look at a ratio practice problem. To get purple paint, a paint store mixes 15 gallons of red paint with 12 gallons of blue paint. What is the ratio of red paint to blue paint? So these are 2 different subjects, different colored paints, and it is asking you to write as a ratio the relationship between the 2. So the relationship written in fraction form can be written like this: red paint over blue paint, where the number on top talks about the amount related to red paint and the number at the bottom related to blue paint. So if you simply replace the numbers as given in the problem, there are 15 gallons of red paint, so you can just put 15 for the number on top, and 12 is the number of gallons of blue paint, and that is the number at the bottom. So the ratio simply is 15 over 12. If needed, you can also reduce it to lowest terms, where you get it to lowest terms by dividing both by a factor of 3, and that would simply look like 5 over 4. And that is this ratio reduced to lowest terms. And again, that's highlighting the fact that ratios written in fraction form behave like fractions, but important to differentiate between the two. Next is proportions. A proportion is a mathematical relationship that shows that two ratios are equal. Why is it important to know about proportions? Because it will help you find the missing term when you are provided with two ratios. The way that you find the missing term is through a method called cross products. And cross products means that you multiply diagonally across the equal sign and see both products are equal. That was a lot of words, so let me show you what I mean. Here we have two ratios that are equivalent. They are the same value, they are the same amount. And the way that we check them is by doing the cross products. So in other words, we look at the numbers that are diagonal to each other and multiply them. And if they are proportional to each other, we should expect that the answer for both of those multiplications are the same or give the same answer. So if we follow the red line, we multiply 4 times 9, and that gives us 36. And we expect that when we multiply the blue line, 3 times 12, it gives us 36, and we see in fact that they do. So proportions is just confirming that two ratios are the same, and are the same value, and we're going to use that information to find a missing term in two ratios when the problem asks us to find that. Let's look at a proportion practice problem. To get purple paint, a paint store mixes 3 gallons of red paint with 2 gallons of blue paint. If the store wants to use the remaining 16 gallons of blue paint, how much red paint do they need? So we are given three values here. We are giving 3 gallons of red paint, 2 gallons of blue paint, and 16 gallons of blue paint. 3 gallons of red paint and 2 gallons of blue paint is how much they normally mix to get purple paint. But now we're asked they're going to do that, but at a higher volume. Now it's 16 gallons of blue paint, and they're asking how much red paint do they need to use all 16 gallons of blue paint. So when you write the ratios, you write them in a proportion format, because that is how we're going to check that they are equivalent. So on one side, we say that for every 2 gallons of blue paint, they mix 3 gallons of red paint. That is the ratio that they normally use to get purple paint. And to keep that ratio equivalent, but now using 16 gallons of blue paint, we say that we write the second ratio with the missing number that we're looking for. So now we're looking with 16 gallons of blue paint, but we don't know the amount of red paint. We use a proportion, we set it up as a proportion, and we do cross products to find the missing term. So we set up the arrows. And when we solve the cross products, again, we're going to use the fact that the answer to both of these cross products, or both of these multiplication problems, will be the same. So we follow the blue line because we know what those numbers are. We say that 3 times 16 is 48. And then we follow the red line and we say that 2 times an unknown amount of red paint is equal to a number we don't know. But we actually do know what that number should be, because again, proportions say that the ratio should be equivalent. So when we multiply 2 times x, it should equal 48, because that is what is going to make the proportion equal. And now we have 2 times x is equal to 48, and we solve that by dividing both values by 2. So we divide 2x by 2, and we divide 48 by 2. This crosses out, or this eliminates cancels out the 2, and we have that the missing amount of red paint is equal to 48 divided by 2, or 24 gallons of red paint. So we do the multiplication of the numbers that we do know, in this case 3 and 16, and we use that answer to find the unknown number. We have a multiplication of 2 times an unknown number. We want that unknown number, but we know what that unknown number, or what that multiplication is going to be. 2 times that unknown number is going to be 48, and we got that 48 from the multiplication of the numbers that we did know. Finally, we have rate. A rate is a specific type of proportion. A rate is a proportion that compares against a quantity of 1. And you actually see rates very commonly in your everyday life. Some examples are when you are driving, you go by miles per hour. Unless someone is watching this outside of the US, then you do kilometers per hour. You also, in terms of salary or how much you'll get paid, you may ask, how much am I getting paid dollars per hour? Another one is miles per gallon. And the indication of a rate is very commonly seen when you see the word per. When you see the word per, it usually means per single amount. So miles per single hour, dollars per single hour, and miles per single gallon. Here is a rate practice problem. A car drove 240 miles on 10 gallons of gasoline. How many miles did the car drive per gallon? Here, we know that it is a rate problem because it gave us the word per. Now, remember, rate is a type of proportion, and a proportion is set up as two ratios that are equal to each other. But in the proportion problem, the problem gave us three numbers. So we knew how to set up the ratio. But here it only gave us two. How do we approach this? Well, we use the fact that rate is a relationship against a quantity of 1. So the number that it didn't explicitly tell us, but we know we can use, is 1. So we set up the ratios as a proportion so that they are equivalent to each other as follows. We were told that a car drove 240 miles on 10 gallons. So that is one of the ratios. That was all the numbers that it gave us, but since it is a rate problem, we are going to set that up as an equivalent ratio against a value of 1 gallon. Because it is per gallon, so it is per single gallon or per 1 gallon. And this is how you set up the ratio. We look at the cross products. So we multiply diagonally. 10 times an unknown number, we don't know what that answer is going to be. So that's already two unknowns. But if we look at the other cross product, we know that 240 times 1 is equal to 240. Any number times 1 is itself. With this information, and again, using the concept that a proportion is equivalent ratios, we can say that 10 times the unknown number is 240, because that is what has to be true for a proportion to hold true. Then we solve for this unknown value or unknown variable, and it simply becomes 240 divided by 10, and the answer is that the car got 24 miles per gallon. So rate is, again, just proportion problems, except that on one side, the ratio is going to have a 1 on it. And that was today's lesson. That was ratios, proportions, and rates, where we saw that rates is a specific form of proportions, and proportions is the mathematical relationship that states that two ratios are equal to each other, or that's how we check that two ratios are equal to each other. Thank you guys so much for watching. I'll see you guys in the next lesson.